This is lesson 1, understanding proportional relationships. This is activity 3, moving twice as fast. And in this activity, we're going to add one more bug, and there's that bug right here. So we have the ladybug and we have the ant, and they're moving at the same speeds as before. But now we have this new bug, and this new bug is going to move twice as fast as the ladybug. So let's watch it move for a second. After 2 seconds, it moves to here. So it's moved twice as far. So in 2 seconds, it moved 8 centimeters, whereas the ladybug, in those same 2 seconds, this is the same line diagram, it moved only 4 centimeters. 1, 2, 3, 4. In 4 seconds, the new bug has moved 16 centimeters. So twice the time, it's moved twice as far. But the ladybug has only moved 8 centimeters. 5, 6, 7, 8. So this new bug is moving twice as fast. So it's actually gaining more. It's moving farther and farther ahead because it's moving faster than the ladybug. After 6 seconds, the new bug has moved out to 24 centimeters, whereas the ladybug has only moved, what's half of 24? Half of 24 is 12. So here's 10, 11, 12. So what does that look like on the graph? So 8 centimeters in 2 seconds, 16 centimeters in 4 seconds. So now we're going to add that new bug to the graph. And notice it starts at 0. So after 0 time, it's moved 0 centimeters. So it goes, the line, the graph goes through 0, 0. It's a proportional relationship. So after 8 centimeters, it takes 2 seconds to travel 8 centimeters, and it takes to travel 16 centimeters, it takes 4 seconds. So you place those 2 points, so 8 centimeters, 2 seconds, and 16 centimeters, 4 seconds. So this is twice the distance, and this is twice the time. So now you draw a line through those points, and it goes through 0, 0, because again, proportional relationship, if there's no time that's gone by, then there's no distance traveled. So here's the line. So this is the new bug. Remember, this is the ladybug, this is the ant, and this is the new bug. So for just a moment, if the new bug is traveling twice as fast, so in 2 seconds, the new bug traveled 8 centimeters, how far does the ladybug take to travel those same 8 centimeters? So you go up to here, and it takes the ladybug twice as long. It takes 4 seconds to travel those same 8 centimeters, whereas it took the new bug only 2 seconds to travel those same 8 centimeters. And the ant is in between. So notice that the bugs, as they travel faster, their lines get less and less steep. So the faster bugs go, the lines go this way. Then I ask you to write an equation for each one of these. So let's go back to where we started a long time ago. The equation has 2 parts to it. On the right side is the slope. On the left side are the x and y values. It's a big deal that all of these lines are proportional. All of these lines go through 0, 0, because we're going to use that in a moment to make writing these equations much, much easier. All right, the slopes. The vertical distance in each case is 1 unit. So this is 1 unit. This is 1 unit. This is 1 unit for the new bug as well. And the horizontal distance is 2, 3, and 4 units. So the slope is the vertical distance over the horizontal distance. So how much time it takes to travel a certain distance. All right, the slope for the ladybug is 1/2. So it takes half as long to travel 2 centimeters. So if you travel 2 centimeters, the time is 1/2 of a second. If you travel 3 centimeters, the time for the ant is 1/3 of a second. So now this gets a little bit tough because this is time on the vertical axis and this is distance on the horizontal axis. So notice that even though the slope is 1/2, this line looks a lot longer than this line, but you want to look at the unit, the time. The time is 1 second and the distance is 2 centimeters. So the units are half. The units in this case are 1/3. So the units of time are 1/3 the units of distance for the ant. And the units of time for the new bug is 1/4 the units of time for the units of distance. The units of time is 1/4 the units of distance. This is hard. All right, so let's zoom out a little bit and look at it all together again. Now the x and y values. So we have the slopes, and we're going to come back to that. We're going to talk through it one more time, and you'll start to get it. But let's get the x and y values, and that's the easy part actually in this case, because it goes through 0, 0. So for the ladybug, the ladybug travels 12 centimeters. That, since it goes through 0, 0, that is the same as the x-coordinate. So that's going to go right here as the x-coordinate. You go out 12 centimeters, and how much time does it take to travel that 12 centimeters? It takes 6 seconds. So notice that the y-coordinate is the same as the vertical distance because it goes through 0, 0. We don't have to shift the triangle at all. We don't have to do all that stuff that we've done in the past. So the horizontal distance is 12 centimeters. The vertical distance is 6 seconds. And notice that 6 seconds is 1/2 the horizontal length, the 12 centimeters. So the number, the unit, is 1/2 of the unit for the horizontal distance. So the x-coordinate is the 12, that's the horizontal distance. The y-coordinate is the 6, that's the vertical distance. So the ratio y to x is 6 to 12, so it's the vertical distance over the horizontal distance, and that simplifies to 1/2. And so here's again to remind you of the slope once again. It's 1 unit vertical distance, 2 units horizontal distance. So the vertical distance is 1/2 the number of units of the horizontal distance. That's probably the way to say it. So the vertical distance is 1/2 the number of units of the horizontal distance. And if you write that out and you just basically say that, the vertical length is 1/2 the horizontal length. That helps you write the equation. The vertical length, which is y in this case, is equal to 1/2 the horizontal length, which is x. So y is equal to 1/2 x for the ladybug. For the ant, same idea. The horizontal length is 15 centimeters, but the vertical length is going to be 1/3 of this 15 centimeters. So the vertical length is going to be 5 centimeters. 5 seconds. So the unit is 5 seconds. And notice that the vertical distance to the horizontal distance is 1/3. So the vertical distance is the number of units for the vertical distance is 1/3 the number of units for the horizontal distance. So the x-coordinate is the same as the horizontal distance, is this 15. The y-coordinate is the same as the vertical distance, is this 5. So the vertical distance compared to the horizontal distance, y to x in this case, they're the same because it goes through 0, 0, is 5 to 15 equals 1/3. And here's the slope once again to remind you. The vertical distance, 1 unit, is 1/3 the horizontal distance, 3 units. So the slope is 1/3. So it's 1/3 the number of units of the horizontal distance. So you just say that and then write the equation. The vertical length is 1/3 the horizontal length. So y equals 1/3 x for the ant. And the new bug, same idea. The horizontal distance is 16 units in this case. That's also the same as the x-coordinate. Why? Because you don't have to shift this at all. It goes through 0, 0. So the x-coordinate is going to be 16. The x-coordinate is going to be 16, and the y-coordinate is going to be these 4 seconds. 1, 2, 3, 4. So the vertical length is the y-coordinate. Again, because you don't have to shift it, so this is going to be 16, 4. And so the equation is y over x. There's no, you don't have to subtract anything, you don't have to add anything. That's equal to the slope, which is, well, first of all, it's equal to 4 over 16, which simplifies actually to the slope, 1 over 4. So notice that the vertical length is 1/4 the number of units as the horizontal length. So this is 1/4 these 4 units. So if you just say that the vertical length is 1/4 the horizontal length, then you can write the equation y is equal to 1/4 x. And notice that the slope, this slope is 1/2 the slope. Yeah, this slope right here is 1/2 the slope of the ladybug, because the new bug is moving twice as fast. So its time is 1/4 the amount of distance, whereas the ladybug's time is 1/2 the distance. So the new bug is moving faster. That's going to take a little while to think about that one. All right, so now we're getting into writing equations from these representations.